Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous two videos we have been constructing deterministic finite automata. Now we are going to solve a little bit complex DFA problems. So let's start with them. The very first question is designing a DFA which accepts strings of at least 3 ones containing. That means from the given input alphabet set 0 and 1, we have to count only the number of ones, not the zeros. In the length question, we have been counting both 0 as well as 1. Now we will be only counting transitions with 1 and will be ignoring 0. Again, 0, Q0 will be the initial state. On the first one, we have to remember that we have seen 1 once. On the second one, we will remember that we have seen 1 twice. On the third one, we will remember that we have seen 1 thrice. You see, this is the final state. Why? Because we have already seen 1 thrice. We have been ignoring 0. Let's see what happens when there are zeros coming up. When zeros are there, we will ignore it. And we will stay in the same state. And whenever the 1 is coming, we will have a transition. Again, zeros are coming if, then we will ignore it. Again, zeros are coming, we will ignore it. Now, once 3 ones are achieved, then it doesn't matter whether zeros are there or ones are there. It is going to be a final state. This DFA will exactly accept those strings which has 3 ones in it. Example, let's say 0 1 0 1 0 1. So 0 will have a transition to Q0, 1 will have a transition here, 0 will have a transition here, then again 1, then again a 0, then again a 1. It will reach the final state. Is it accepting 1 1? No. Let's see. With 1 1, it will have a transition from Q0 to Q1 and a transition from Q1 to Q2, and Q2 is a non-final state. So 1 1 is not accepted, but 0 1 0 1 0 1 is accepted because 0 1 0 1 0 1 contains exactly 3 ones in it. Mathematical definition. Let's name this machine 8. Q, sigma, delta, Q naught, and F. Here Q is set of states which are Q0, Q1, Q2 and Q3. Sigma is input set which is 0 and 1 in our case. Delta, let's draw the transition table. We have here Q0, Q1, Q2 and Q3. Out of them, Q0 is the initial state and Q3 is the final state. On input alphabet 0 and 1. Q0 on 0 is transiting to 0 only. On 1, it is going to Q1. Q1 on a 0 is staying in Q1 only. On 1, it will go to Q2. Q2 on 0, it will be staying back to Q2 only. On 1, it will go to Q3. Q3 on 0 will be on Q3, Q3 on 1 is also going to be on Q3 because we already finished with 3 ones. So we have discussed what is Q over here, what is sigma, what is delta. Q naught is again the initial state. Final state over here, F, is just Q3. Let's see one more example. Now this is counting and accepting those strings which contains exactly 3 ones. That means it will reject strings having ones more than 3 as well as less than 3. It will accept only those strings which is containing exactly 3 ones in it. So we'll start with the initial state Q0. On the first one, we will have a transition to Q1. On a second one, we will have a transition to Q2. On the third one, we will have a transition to Q3. Now this is going to accept 3 ones. Now if more than 3 ones are there, we have to reject them. In the last case, it was at least 3 ones, so we were accepting even more than 3 ones. Now it is exactly 3 ones. That means we have to reject even ones more than 3. So we will have a trap state over here. Now we'll have to consider the zeros. ignoring 0, staying back to the same state, ignoring 0, staying back to the same state, same here, same here. Now here, after the fourth one, it doesn't matter whether 0 or a 1, it is never going to contain exactly 3 ones, hence everything is rejected. Mathematically it is Q, sigma, delta, Q naught and F. Over here Q is the set of states, Q0, Q1, Q2, Q3 and Q4. Input alphabet set is 0 and 1. Let's try to draw delta in the table form. On Q0, Q1, Q2, Q3 and Q4 states. Input alphabet 0 and 1. Initial state is Q0 and final state is Q3. On 0, it is staying back to Q0. On 1, it is going to Q1. On 0, it is staying back on Q1. And on 1, it is going to Q2. On Q2, it will stay back on Q2 unless it is 0. And it will go to Q3 on a 1. Q3 is going to stay back in Q3 itself unless it is 0, and then it will have a transition to Q4. Q4 is having a transition to Q4 only, having either the input symbol 0 or the input symbol 1. So here we have discussed the input alphabet sigma, number of states Q, transition function delta, again initial state is Q0, final state F is Q3. Let's see the next model. That is a DFA which accepts strings of at most 3 ones. Now we will have to keep track of number of ones again. Let's say Q0 is the initial state. On the first one we are counting, we have encountered 1. Second one, we are again counting it. We are again counting it. Now we have visited 3 ones. If one more time 1 is encountered, that means now it will never have at most 3 ones. This is going to be a trap state. We will have to consider zeros. We will ignore zeros, so we will stay back in the same state from all these states. Q0 will be a trap state, so it doesn't matter whether 0 or 1, we will stay back to Q4. Now, which are our final states? We know that it is allowing at most 3 ones. That means 0 ones are accepted, 1 time 1 is accepted, 2 time 1 is accepted, 3 time 1 is accepted, more than that is not accepted. So here Q0, Q1, Q2 and Q3 are our final state and Q4 is our trap state. Mathematically, what is it? Let's name them M10 machine. Q, sigma, delta, Q naught, F. Q is a set of states. Here it is Q0, Q1, Q2, Q3 and Q4. Sigma is the input alphabet, that is 0 and 1 for the given context. Delta, let's try to draw delta. Q0, Q1, Q2, Q3, Q4. Out of them, Q0 is initial state, Q0 is final, Q1 is final, Q2 is final, Q3 is final, Q4 is non-final. Alphabet is 0 and 1. On 0, Q0 is transiting to Q0. On 1, it is going to Q1. Q1 on 0, on Q1, Q1 on 1, Q2. Q2 on 0, on Q2, Q2 on 1, Q3. Q3 on 0, Q3, Q3 on 1, Q4. As Q4 is a trap state, on 0 or 1, it is transiting to itself. We have seen Q, we have seen sigma, we have seen delta. Q naught is again the initial state, F is the final state. Here, F contains all these states, Q0, Q1, Q2 and Q3. So this is final states. We have seen an example in which we were tracking the length and finding whether the length was 2 mod 3. Now let's design an automata which counts the number of A's and it will accept those strings which contains the number of ones. exactly 2 mod 3. Initial state is Q0. It is counting ones. So on 1, it is going to Q1. Now it is 1 mod 3. This is 2 mod 3. And when it comes back, it is 0 mod 3. We were ignoring 0. Let's put the 0. On 0, it will be staying back to the same states. We want 2 mod 3, so our final state will be Q2. Mathematically, it is machine. Let's say M11, Q, sigma, delta, Q0, and F. Q is a set of states. Here it is Q0, Q1, and Q2. Sigma is the input alphabet, 0 and 1. Delta, for the given context, Q0, Q1, Q2. Q0 is the initial state, Q2 is the final state on 0 and 1. On 0, Q0 has a transition to Q0, and on 1, it has a transition to Q1. Q1 has a transition to Q1 itself on 0, and Q2 on 1. Q2 have a transition to Q2 on 0, and Q0 on 1. We have seen Q, we have seen sigma, we have seen delta. Q0 is again the initial state, and the set of final state will have only one state over here, that is Q2. We have seen various models. Now let's see a very complicated model of a DFA. Now in this DFA, we are going to accept strings which is counting both zeros and ones. Here the number of ones are considered to be 0 modulus 3, and the number of ones are considered 2 modulus 3. So we have to count both zeros and ones. We will start again with a Q0 as the initial state. Let's say we are counting zeros. On the first 0, let's say we are going to Q1. On the second 0, we are going to Q2. Now we have already counted 2 zeros. Now on the third one, this will go back to Q0. Now this completes the cycle of 0. Similarly, we will have the cycles of 1. 1, it will go to, let's say, Q3. On one more 1, it will go to Q4. And on one more 1, it will come back to Q0. Now we will have more states. I'm naming them Q5, Q6, Q7, and Q8. Completing the same way, you will see that all the states are counting the number of zeros and the number of ones. Let's name them. You see, Q0 counts the number of zeros as well as the number of ones, and it is 0 modulus 3, 0 modulus 3 for both. Q1 counts the number of zeros is 1 and the number of ones are 0. Here the number of zeros visited is 2 modulus 3 as well as the number of 1 visited is 2 modulus 3. Now we have to find the final state for the given question. Now the given question says that the number of 1 is 0 modulus 3 and the number of zeros are 2 modulus 3. So number of 0, 2 modulus 3 comes in this line, and the number of ones 0 comes in this line. So it has to be Q2. Now Q2 is the state which has number of ones visited is 0 modulus 3 and number of 0 visited is 2 modulus 3. So mathematically, let's define. We have Q, sigma, delta, Q0, F. Q is set of states which are here: Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7, and Q8. Sigma is again 0 and 1. Try to draw delta. Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7 and Q8. These are the states. On 0 and 1 we have various transition. Let's say from Q0 on 0 we have a transition to Q1, and 1 we have a transition to Q3. From Q1 on 0 we have a transition to Q2, and on 1 we have a transition to Q5. On Q2 on a 0 we will have a transition to Q0, on 1 we will have a transition to Q7. Similarly, from Q3 on a 0 we will have a transition to Q5, on 1 we will have a transition to Q4. From Q4 on a 0 we will have a transition to Q6, on 1 we will have a transition to Q0. From Q5 we will have a transition to Q7 on 0 and Q6 on 1. From Q6 we will have a transition to Q8 on a 0, and we will have Q1 on 1. From Q7 we will have a transition. On 0 we will have a transition to Q3, which will be represented like this, and on 1 it will have a transition to Q8. From Q8 on a 0 it will have a transition to Q4, and on 1 it will have a transition to Q2. This completes this DFA. Such complicated questions could be solved using a deterministic finite automata. We have seen Q, we have seen sigma, we have seen delta, we have seen Q naught as the initial state, and the final state over here is going to be Q2. With this, we are done with this topic. Thank you for watching. Stay tuned to Ekeeda channel and do subscribe. Thank you.